Welcome to join our webinar today. Together with my name is Luis, and together with my colleague Taylor, we will present you some, I would say, information regarding the cybersecurity standards and how InHand and our solution will be aligned with these standards. Let's get started. Some brief contents. We will start with some backgrounds with data breach, some quick facts in IoT. And then we will spend quite a lot of time on the details of cybersecurity standards. Then we will walk through the InHand solution, our approaches. Finally, is some use cases and future trends of the cybersecurity. Okay, first, I would say some historical information. Back in 2002, the average cost of data breaches per hour worldwide was about only $2,500 US. And 20 years after that, the costs went up to $787,000 US. And the number or victim counts per hour worldwide, the reported count, back in 2002, it was only 6. And the 20 years after that, in 2022, it is 97. Some other quick facts in the cybersecurity. So on the left part, you can see here is some score according to National Cybersecurity Index. The strongest measures, I mean, for in different countries. So as you can see, Poland is the #1, and all of them are considered European countries. And on the right part, you can see Asia, Europe, and North America are the top 3 regions where the organizations are more at risk of cybercrime. To address these growing risks, Europe has taken a proactive stance on IoT security. The region is at the forefront of developing regulatory frameworks and industry standards to ensure that IoT systems are secure and resilient. Some key initiatives such as the GDPR, NIS2 directive, and the Cybersecurity Act focus on safeguarding both personal data and critical infrastructure from cyber threats. Additionally, industry standards like IEC 62443 and EN 303645 are helping to establish best practice for securing IoT devices and networks. So you've heard the keywords IEC 62443. What is it? It is an international standard that provides a comprehensive framework for securing industrial automation and control systems. It was developed by the International Electrotechnical Commission, IEC, and the goal is to address the cybersecurity needs of industrial systems. As you can see from the charts, it has, I would say, 5 aspects. The first one is holistic approach to cybersecurity, where the IEC 62443 covers the entire lifecycle of industrial systems, from design and development to operation and maintenance. It provides guidelines for manufacturers, system integrators, and asset owners on how to secure both individual components and the overall system. The second aspect, zones and conduits model, which introduced the concept of segmenting industrial networks into security zones, each with its own security requirements. These nodes are connected through a term called conduits, which control communication between them. The third aspect is security levels. The standard defines different security levels based on the degree of protection needed. Each level corresponds to the increasing measures against different types of cyber attacks. We will talk about some more details later. The fourth aspect is role-based guidance. The IEC 62443 provides specific guidance for various stakeholders in the industrial ecosystem, which includes components manufacturers, system integrators, and asset owners. The last aspect is risk assessments and management. The standard emphasizes the importance of risk assessments and implementing security controls tailored to those the unique needs of each industrial environment. So as IoT devices become more common in the industrial environment, the risk of cyber threats grows over days. IEC 62443 ensures that the IoT systems are designed and maintained with cybersecurity in mind. In Europe, many industries are adopting IEC 62443 to align with regional cybersecurity initiatives and ensure compliance with evolving regulatory frameworks such as the NIS2 directive we mentioned. Okay, and as you can see from this page, the IEC 62443, it has four main categories. The first one is general, where it defines the core terminology concepts. The second one is for policies and procedures, where it defines the requirements of effective cybersecurity management. The third one is for system, where it focuses more on the ICS system level design and risk assessments. The fourth one is for components, where it pays attention to securing product developments and ongoing lifecycle maintenance of the intelligent devices in an ICS. So InHand as a manufacturer and our products fall into the fourth category, components. And below the component category, as you see, there are two standards, the IEC 62443-4-1 and -4-2. What are the difference between them? We then made a quick comparison between these two standards. First, they have different focuses. The IEC-4-1, it focuses on more secure products development lifecycle, where the -2 focuses more on technical security requirements for the components. The scope of the -1, its processes and the practice to ensure secure design, development, and maintenance of the products, where the -2, it has a scope of specific technical security features and the capabilities of the components. The target audience for -1 is the developers and the manufacturers, where the -2 has a target audience, which are users, integrators, and operators. So the main goal of the -1 is to ensure the products are developed securely from the outset. For -2, the main goal is to ensure that the components have a built-in security features that meets specific security requirements. So to summarize, the IEC 62443-4-1 is about ensuring the products that are developed securely, focusing on the process that manufacturers should follow. The IEC 62443-4-2 is more about ensuring that the products, they have the necessary security features built in, focusing on the technical controls that individual components must meet. So for a manufacturer, for the organization, the IEC 62443 defines 5 levels of maturity, as you can see from the chart, from initial to improving. So there are 5 levels, which each level progressing to more advanced level of performance at the organizational level. Service providers and asset manufacturers are required to identify the maturity level associated with the implementation of each requirement. The maturity levels demonstrate to the customers how robust and strong the cybersecurity policies and practices are of the suppliers, of the organization. So as for InHand Networks, we are now officially certified at maturity level 3, where we have established and documented processes as well as defined training schemas for personnel. There are another concept I would like to point out. It is more for the components parts. So should be -4-2. As you can see, there are 5 security levels grades, ranging from 0 to 4, with level 0 identified as the minimum level of risk and security level 4 as the maximum or most vulnerable level. To meet the security requirements of each security level, it is critical for the industrial system to have suitable protection for uptime, safety, and intellectual property. So industrial stakeholders operating within this industrial ecosystem can take advantage of clear expectations from asset owners and operators. So we've talked about quite a lot with the standard itself. Let's talk about the InHand approach. What did we do to meet the standard requirements? First, we are continuously trying our best to have a more secured organization, where we have implemented a security review on defining design and developments on the different phases of the life cycle. And we have a dedicated security engineer in place to oversee all the process. And we are using the Microsoft threat modeling tool for threat modeling of devices like IR300, based on frameworks like the Stride LM and continuous updates as needed. We also implemented specific processes for security assessments of third-party software components and open source components. The second approach is about the protection against intrusions and attacks. To resist the intrusions and attacks, the system must be equipped with a robust access control mechanism, which that can identify, authenticate, and authorize different users. In this part, we implement account management feature, access control, and password authentication. So if a login fails, you'll be able to configure lockdown time. And for example, you will also be able to configure the password complexity requirements. Third one, in the industrial internet applications, the data collected plays a very important role in improving production efficiency. So industrial operators are making every effort to ensure data integrity. Here at InHand, we implemented, for example, secured HTTPS, ACL, VPN, DMZ, demilitarized zone, and TPM 2.0. The file system is by default is set to read only. There will be no third party that can be able to modify. And there is also validity detection of configuration in place. Then edge computing is a trend in the industrial internet, industrial IoT, And the trustworthiness and reliability of various customized edge applications are crucial for system security. In this part, we implement features like secure boots and trust zone. And to guard against the potential threats, it is also necessary to continuously monitor the network and review cybersecurity incidents. In order to do that, we'll be able to offer security logs. We have also a coordinated vulnerability disclosure CVD system in place, and we have a product security incident response team in place. So with all that efforts, today InHand Networks, we are officially certified by IEC 62443-4-1 as a manufacturer, as an organization. As you can see the certificates on the right part. Together with that, we have certified our high runner products, the IR300, the IG502, IG5902, and also EC300. These high runner product models are today certified with IEC 62443-4-2. And we are working still to certify other product lines in the future to come. So now let me hand it over to Taylor, who is going to present some specific real-time real features from these products.
Okay, Louis just talked about the approaches provided by InHand to resist network attacks and enhance data protection capabilities. Next, I would like to demonstrate the functions that we can use in our daily configurations to enhance the cybersecurity efforts. I will take IR302 and EC312 as examples to share the features. Okay, let's start with IR302. Firstly, regarding the admin access function, this feature allows for the configuration of access service strategies, such as set whether to permit remote telnet access to a router. Additionally, you can set a timeout value to ensure that users are automatically logged out if they forget to do so before they leaving. Furthermore, by default, if a user fails to log in multiple times due to the incorrect password, their IP address will be temporarily blocked and will be released after a specific period. Next, firewall functions. In the product list, you can see we provide rich firewall functions like device access filtering and content filtering. These functions can effectively protect the device from suspicious IP access. For instance, if you notice that remote access to a router is very slow, or that the router is consuming a large amount of data traffic, you can check the router's logs and also analyze the captured packet files. This may indicate that the router is experiencing a DDoS attack. At this point, you can set some firewall rules based on the actual situation to prevent the attack. Okay, now we go to VPN function, the virtual private network. By establishing the VPN terminals between stations, the transmitted sensitive data can be well protected. As you can see, IR302 supports various types of VPN for matching different peer-owned devices. Okay, now let's turn our attention to EC312. I believe many of you are already aware that our EC series offers a distributed Linux operating system that is highly flexible and open for users. However, it is important to note that this flexibility may expose users to potential security threats. Therefore, we are actively enhancing our EC products to improve the security protections, and all have already implemented several measures to this regard. Firstly, similar to other InHand products, EC312 supports several software features designed for security protection, such as the firewall and VPN functions. Especially, EC312 allows users to input the commands to add firewall rules on the web interface. In addition, EC312 offers hardware approaches to safeguard the device and its data, especially through the secure boot and TPM2 technology. Just as its name implies, during the startup process, the device checks the validity of the sensor image. If any illegal and abnormal changes was checked out, the device will not start. This can prevent the sensor from being maliciously tampered with, which may cause security risk and cause huge loss to the customer's business. And TPM is a short name of Trusted Platform Module. It is the kind of microcontroller which is designed to provide the hardware-level security features for storing encryption keys, certificates, and other sensitive data. It supports multiple encryption operations such as key generation and data encryption, and ensure these operations are executed in a secure environment. Okay, I think that's all I want to share with you. Thank you for your attention. And next, I will hand it over to Luis, and he will present some case studies for EC312.
Okay, thank you, Taylor. So let's continue with some of the use cases. I think there are two. The first one is with a world-leading manufacturer of air compressors. So it's Insurrent that requires predictive maintenance through IoT technology for data acquisition and remote supervision. So while enabling predictive maintenance of the equipment, the factories are also at risk of data breaches and cyber attacks. So for this case, we have supplied the EC312 edge computer, and it is used for bi-directional data encryption and authentication. And the device certificate is stored securely through TPM to ensure the security of the system. The ways the EC312 implemented, the factory has increased productivity while ensuring network security and reducing the risk of downtime and cyber attacks. The second use case is also with EC312. The customer is from China. It's called Shuohua Power, who is a solution provider for energy management system and battery management system. So industrial and commercial energy storage is an important part of today's energy developments, and they often use EMS system for on-site management. The EMS system is the core of the stable operation of energy storage system. So in this case, EC312 is used to store keys through TPM, similar as Taylor mentioned at startup stage. The edge computer will use these keys to verify the legitimacy of the EMS system. Only verified application can be loaded and executed to prevent data leakage and malicious intrusions. So the operations with the EC312 in place, the operation stability and safety of the energy storage system were greatly improved. Then I would like to talk about some of the future trends. The first one, manufacturers are increasingly adopting a secure by design mindset, embedding security from the very beginning of the product development. This involves hardware-based security, encryption, and secure boots mechanism for IoT devices. The second trend, AI-based solutions are being deployed to detect anomalous behavior and mitigate cybersecurity threats in real time. So these systems help to identify zero-day attacks and improve the response times to cyber incidents. The third trend, with the rollout of 5G networks, the number of connected devices is expected to grow dramatically. 5G's low latency and high-speed connectivity open up new use cases for IoT for sure, but also bring challenges for security, requiring network segmentation, encryption, and enhanced access controls. The fourth trend, European industries are placing more emphasis on securing the IoT supply chain. So with more components sourced global-wide, ensuring that the software, firmware, and hardware are free from vulnerabilities and backdoors is a top priority. The fifth trend, as more IoT applications move from cloud to edge computing, securing the edge side becomes more critical. This includes securing communications between devices, ensuring data integrity, and preventing unauthorized access to local data storage. So with these trends, InHand will keep trying our best to make our solution more and more secured. Okay, I think that's all for today. Before we wrap up, some quick introduction for InHand Networks. In case you are not familiar with us, we are a industrial IoT communication solution provider. We established over 23 years ago. We are shipping our products to over 60 countries and over 3 million products deployed already worldwide. And we have our own manufacturing facilities. The main facility is in China, and we have product facilities, also smaller ones in Thailand, in Bangkok, and Toronto in Canada. With these about 18,000 square meters of manufacturing sites, we have 7 production lines with high level of flexibility, and we can produce up to 3,000 pieces per day. So our lead time is pretty good. Okay, I think that's everything we would like to share today. If you have any questions, feel free to type in the chat box. We will try to answer everyone. Thank you again for joining us. We should have a good rest of the day.